Hello everyone, Jai Hind and welcome to the platform of PMF IAS. And from today onwards, we'll be starting off with geography. All right, we'll be studying geography in our sessions and we'll be starting with the geography from today onwards. All right, now when I'm talking about geography, geography as a subject holds very importance for your upcoming examinations. All right, whether it is your prelims or it is your mains. So geography holds a very importance, and alongside geography is also, it builds the foundation for your complete journey. So today we'll be talking about geography, how it, as a subject, how should we deal with geography. Along with this, we'll be talking about the universe and the solar system as well. So for those students who were present in my last class, this would be a kind of a quick revision. All right, so we had discussed universe and a bit of solar system in our previous class, but actually because of the shifting and everything that was being done and for conducting your classes smoothly, so we had to stop in between and again we have to start back again. So today again I'll be taking this session and it will be a quick revision if you were there in the previous class. Also, let me tell you that the board has been already shipped. It has reached here and probably in a day or two we will have the classes on these smart boards. Okay, we'll not be having class like this. We'll be having classes on the smart board from in a day or two. All right, so let's start the session. Let us move ahead. I hope I am audible to everyone. If I'm audible, just give me a thumbs up. Am I audible? Okay, great. Okay, thank you, Sonali. All right. So let's start the session and let's discuss what is geography and what everything is. All right. So let's start the session right now. Now, when we are talking about geography, before moving ahead, let me tell you a bit about myself. Who am I? So I am ex-NDA 115th course. My name is Bhavar Singh Sirohi. All right. I qualified civil services IAS in 2012, even qualified SSC CGL, but I'm more inclined towards taking sessions, guiding students. So I have been a faculty for more than 10 plus years. And I worked previously with Byju's as well as with an academy as well. Now, as I have told you, that geography, it helps in building foundation. All right. How it helps in building foundation, that is very important. All right. So when you are starting your journey, when you are starting your journey, when you are starting your UPSC journey, so what happens is that there is a foundation that had to be laid, all right, for constructing anything, whether it is a building, whether it is, any kind of monument that you have to construct, you have to lay down the foundation. And geography for the UPSC, it helps in building the foundation. Why? Because geography, when we'll be talking about physical geography, all right, when we'll be talking about physical geography, there would be lots of, we'll have the, there would be, in physical geography, when we talk about, physical geography, most of the things that are there, they are related to, they are related to science, or you can say that it is conceptual knowledge that is there. So when we talk about the concepts, all right, the concepts helps in building the foundation for the other subjects as well. All right, so we have different subjects which are there. So what happens is that when you study geography, so this complete knowledge helps in building that conceptual groundwork. All right. So when we study landforms, when we study climate, resources, and as well as disasters, so these all things let you understand that why or how the things work or how we had different rise and the spread of the civilization. So when you study history, of course, the landforms, all right, when we are talking about the Magadhan Empire, why Magadhan Empire was, it started in its particular place, because that was easily, there was water that was available through Ganges. All right, the landform that is there, it was, economically, when we are talking about economically, it was rich in various resources that were there. So when we are studying history, And if you have that conceptual knowledge of the complete landforms, the climate, resources which are there, so that helps in building your foundation for geography, for history as well. It helps in building the foundation for polity as well. All right, when you are studying polity, so the concepts like federalism, the regionalism, so such kind of concepts, again, when I'm talking about geography, it helps in building that foundation. All right, for the economy as well, different kind of resources, where are we have different types of resources which are there, the trade routes which develop. So again, you will have an in-depth knowledge only when you have the complete knowledge of the geographical surrounding. And of course, environment, it deals with the completely geographical setup, because climate is the major driving force behind the environment of any place. So all these things you understand when you understand the conceptual knowledge of the geography. As well as when we are moving ahead, when we are studying geography, it boosts the map skills, all right, visual memory. So see, when we are talking about the complete syllabus of your UPSC, it's very, very vast syllabus that is there. You have to know everything, you have to understand everything. And when your map skills, your visual memory are boosted, so what happens is, instead of mugging everything, instead of rotting everything, what happens is you start to visualize, and that helps you in remembering things for a longer duration. So again, here geography helps us. And also, when we talk about environment, disaster management, or even international relations, geopolitics, geoeconomics, all right, all these are closely linked to the geography. So whatever the, when we are talking about geopolitics, now we are moving from geopolitics to geoeconomics. So all these things you come to understand when you are understanding geography well. So that is why the foundation or the geography is a very important subject. Now, let me tell you how you should study geography. As there are in all these subjects, even if you are studying biology, physics, or chemistry, or you are studying technology, or you are studying history, or history is mostly it is the factual knowledge. All right, facts are there. But in geography, we have both the things. We have certain facts which are there. We have also concepts. So when you are studying geography, I will suggest that there are facts. So what you should do is you should start learning those facts. And because most of the geographical phenomena, they are based on concept. For concept, you do not need to rot everything. All right, you do not need to mug up everything. What you need is that you need to understand those concepts. As your conceptual knowledge will get built up, and alongside, if you will keep revising the facts, when you combine both of them, you will learn geography as a whole. So that is what is required. All right, and how you can study geography well together. Now, coming to the development of geography as a subject, how geography developed. So what happened was, in the ancient times, there were ancient civilizations like Babylonians were there, Assyrians were there, or Phoenicians were there. They made several observations about world as well as the celestial bodies. Later on came the Greeks. The early geographers, or the earliest geographers were the Greeks, because they laid the scientific foundation of the geography as a subject. All right. Like, for example, when we talk about Eratosthenes is known as the father of geography. He calculated circumference of the earth. All right, closely. It was very closely related to the circumference of the earth, although not correct. I mean, not accurate, but it was very close to the circumference of the earth that we know today. So, the Greeks, they tried and they used mathematical operations and tried to lay the foundation for the scientific geography. Later on in the medieval period, what happened was the Arab scholars, because at that point of time, the Arab civilizations, they started to emerge, and later on they were migrating to different places of the world. So while they were migrating, so they started contributing towards the map making or cartography. What is cartography? the art or the science of map making is called as cartography. So they made contribution, like Al-Idrisi is there, he made, or the other Arab scholars, they made different contribution to cartography, as well as they enhanced the geographical knowledge. In the modern period, when Renaissance happened, so after Renaissance, you all know that there was, after Renaissance, what happened was there was Industrial Revolution. And later on that Industrial Revolution, because of that, there was ample amount of production of the material. Like we all know that in Britain or in UK, what started was the cloth making, the textiles, they started generating more of cloth. So earlier they were dependent on hand woven cloths, but now when we had the industrial revolution, the finished products, there was ample amount of opportunity to search for the markets. So when they began searching for the market, that led to the exploration. And that exploration again led to map making or cartography, the contribution towards, and later on, there was environmental determinism and quantitative revolution that happened during the modern period. Right now, geography is majorly developed, or it is basically focused on the development aspect. When we are developing any region, what happens is that we look for the geographical structure of that area. Why? So that the development can be, it could be in the you can say in the line, or it could complement the structure. Because if the development and the structure, geological structure of that particular place is different, or what happens is that if they are mismatched, so ultimately what will happen is that the development will not be full-fledged. So that is how the geography has developed over a period of decades. Now, like I said, geography is composed of two words. It is geographos. All right, there is a Greek word geographos from which geography came. Geographos means writing about the earth, or graphos is writing and geo is about the earth. The term geography, it was coined by Eratosthenes. Eratosthenes coined this term, and also he is called as father of geography. He is called as father of geography. I hope that whatever I am writing is clear and visible to every one of you. Or should I change the pen? What I am writing on the screen is visible to everyone? Okay, that's nice, Sonali. Thank you for confirming. All right, so Eratosthenes was called, or he's still known as the father of geography. So when we talk about geography, geography is concerned about everything that is there, whether it is the landforms, the features that we see on the lands, the people who are staying here, and also the different phenomena of the earth. So land, feature, and everything that comes under the when we talk about geomorphology, morphology means structure. So the structure of the land or structure of the earth, any structure that you find, that is included in geomorphology. When we talk about inhabitants, so that becomes the social geography, all right, and or you can say human geography. And therefore, we have two different major subdivisions of geography in which we study geography. We have physical geography that deals with everything that we see on the structure of the earth, and the human geography, or the social aspect of the geography. It was Ptolemy who wrote Guide to Geography in 2nd century, and he defined geography as a representation in pictures of the whole known world together with the phenomena which is contained therein. That means that during that point of time, what was there? It was basically the map making that was majorly focused at. Now, so this was Eratosthenes. You can see this was the map work of Eratosthenes, the earliest map or its representation that could be found. All right, so this was the map of the world. was the map of the world that was earliest, it was by Aristophanes. You can see various features over here. All right. And at the same time, you can see that this was how he calculated the circumference of the Earth. All right. So this was asked in, I guess, there was a either last year or last to last year. There was a question about which two places he used to calculate the circumference. So he calculated circumference using two places, Alexandria as well as Scene. It's in Aswan. All right. So between these two, points, he measured the shadow of a pole, and then on the basis of that, he calculated the complete circumference of the Earth. Now, when we talk about geography, like I said, it is a kind of interdisciplinary approach, or you can say that geography is what you can say is linked to different sciences. Geography, when we talk about the various structure, the relief features that we find, it could be closely linked to geology. All right, that is geomorphology is connected to geomorphology is connected to geology. Climatology, when we study about the climate of a place, the temperature, the rainfall, the pattern of the distribution of rainfall, that is actually, it happens, or it is the phenomena, the meteorological phenomena, it is studied in meteorology. In the same way, oceanography is linked to hydrology, soil geography is linked to pedology, and phytogeography or zoo geography is linked to biology, whether it is botany or zoology. In the same manner, human ecology is linked to ecology, environmental geography, cultural geography, geographical thoughts, social geography, historical geography. So these are different branches of geography. And these branches are interwoven with the different science or social sciences that are there. And that makes geography unique. And that is why when I say that geography helps in building the foundation, it does not just build your foundation for geography, it builds the foundation for a very wide, you can say, disciplines that are there. So this is how we have the, on the basis of systematic approach, we have different branches of geography that are there, whether it is the physical geography. In physical geography, we study the complete, we study climatology, hydrology, geomorphology, soil geography, the plant geography, all these things we cover in the, when we talk about the interface biogeography. And in the same manner, we have the human geography as well. In human geography, we study the social and cultural setups, the population and settlements, the economic geography, how different economic resources or the industries have been based at different places. All right. Now, when we talk about, let's start with the universe. So I have told you in my previous session as well. All right, this is just a quick revision about everything. So the universe is the totality of everything. Anything that is known or it is supposed, anything that is known to us or it is supposed or unknown objects as well, which are there. So everything that is there, totality of everything is, it is nothing but the universe. So it includes all the celestial bodies or the objects. So we have different stars, we have planets, satellites, as well as asteroids, dust particles, gases that are there, or even, we have the space that is there. So what is universe? Anything that is space and time. All right. So that is universe. All existing matter and the space as a whole is universe. Now, when you talk about the structure of the universe, in certain books you will find that they have declared structure of the universe as negative curvature. All right. However, the size or the shape of or the structure of the universe, it can take or it can, mold itself into one of the three forms. It is not necessary that it will be existing in one particular shape. So it could be flat, just like a sheet of paper. So it could be completely flat, or it could be closed like a sphere or in a spherical module, or it can also be open just like a saddle or a negative curvature. All right. So you can see it can have all the three forms. It could be closed like a spherical, it could be open, and it could also be flat just like a sheet of paper. Now, when we talk about different words that are there, all right, so at various point of time, you must have read cosmology or astronomy, all right. So sometimes we get confused about these two different words. What is cosmology? What is astronomy? So cosmology is basically nothing but the study of origin of universe. How our universe came into existence. So that is what we call as cosmology, origin and evolution of the universe. So it is actually, cosmology is a very small field which is inside astronomy. All right, astronomy is a bigger sphere. So in astronomy, it is a broad field, and in this broad field, we focus everything of the space or anything of the space. So whether it is, planetary science or stellar astronomy, galactic astronomy, extragalactic astronomy, galaxies, everything we study in astronomy, but within the astronomy, we have cosmology. Cosmology specifically deals with the origin and the evolution of the earth. All right. And then we have astrophysics. Astrophysics, it concentrates on the physical and the chemical structure of all the celestial objects which are there. So it studies the physical and the chemical structure. So that is the difference between astronomy, astrophysics and cosmology. So astrophysics and cosmology are basically, they are the branches of astronomy. All right. Now, when we talk about the cosmology, let's talk about the origin of the universe. So there were various modules that were there suggesting the origin of our universe. All right. Even the earliest, when we're talking about the early phases, so during those early phases, it was that, the earth is spinning on a turtle's back. So there were certain theories that were put forward during the earliest time, because man, as a social animal, he is very curious. We are all curious how anything originated, how it happened. So, human beings at that point of time were also curious, and they wanted to understand how our earth came into existence, how we came into existence, why everything came into existence. So for this, what happened was, earliest human being, they and Ptolemy was the front runner. He was the former, first person who considered that Earth is the center of the universe. He said that Earth is the center of the universe, and that led to origin of geocentric theory. So in geocentric theory, what it is, geo plus centric. Geo means Earth, centric means center of the universe. So in geocentric model, he said that the Earth is the center of the universe and the complete universe is revolving around our Earth. So that was the geocentric model. However, later on, Copernicus in 1543 gave this idea that it is not the Earth which is the center of the universe, but it is the Sun that is the center of the universe, and that led to formation of the heliocentric theory. Helios means sun and centric means center. So heliocentric model means that the sun is the center of the universe and this universe is rotating or revolving around the sun. However, later on, Herschel in 1805 said that the solar system itself is part of the galaxy. All right, our solar system is part of a galaxy, and later on, Edwin Hubble, on whose name we have the Hubble telescope as well, Edwin Hubble said that the universe is actually not composed of single galaxies, but it is composed of various galaxies. Many galaxies can be found in the universe. The most prominent theory about the origin of the universe came in the form of the Big Bang. The Big Bang theory, it said that there was a vast explosion that led to the starting of or the origin of the universe. This Big Bang theory was proposed by Georges Lemaitre in 1927, and later on it was modified and given the evidences by George Gamow. Please remember both these names. All right, these names are important. The Big Bang theory was propounded or it was proposed by Georges Lemaitre. Later on, modern Big Bang theory or the strong evidences were given by George Gamow. And according to this Big Bang theory, what happened was that the complete universe that you see today, it was in the earliest time, it was concentrated in a single atom, or it was concentrated in a tiny ball. This tiny ball, it can be called as a singular atom or primeval atom or primordial atom. You can find any terms describing this tiny ball. So as this tiny ball was, everything was, concentrated. So what happens when concentrated? We concentrate matter, we closely pack the matter, the entropy or the internal heat, it rises. So there was lot of heat that was there. And this heat led to the vast explosion. This vast explosion occurred. It occurred around 13.8 billion years ago. 13.8 billion years ago, we had this explosion. This explosion is called as the Big Bang. Bang-like explosion. So that is why this theory is called as Big Bang theory. So what happened was there was a Big Bang or a vast explosion that occurred, and later on, the matter started generating. So there was space, there was time. So before this, there was no space. Before this, there was no time, and that is called as point of singularity. All right, what is point of singularity? Point of singularity is before which there was no time, no space that existed. Everything was in a single tiny ball, and after this explosion, the space and time, both of them, they emerged. Slowly and slowly, what happened was that the materials, they started forming. Initially, the electrons, protons and neutrons were formed. And as the electrons, protons or neutrons were being formed, there were dark ages. Why were there dark ages? Because there was no atom that could be found at that point of time. So after Big Bang, there was Big Bang. Before this, there was point of singularity. Then Big Bang, then what happened was Dark Ages. So in Dark Ages, what happened was during this period of time, there were electrons and protons that were being formed. And later on, these electrons, protons, they emerged and they combined together to form the atoms. So when the atoms were formed, the first atom, that is, we have what? We have hydrogen. So hydrogen was formed. It was the first atom that was formed. Later on, due to nuclear fusion, because there was heavy heat that was there generated, heavily heat was generated during the formation of the universe. There was vast explosion. So heat was there and hydrogen was there. So because of this, the hydrogen atoms, they started combining together, and when they combined together, there was what happened? There was nuclear fusion that happened. Nuclear fusion, what is nuclear fusion? In which two atoms of a smaller nuclei, they combine to form a bigger atom. All right. So this is what we call as nuclear fusion. And during this nuclear fusion, what happens is this nuclear fusion gives off the heat as well as light. So the first stars, they started to get emerged. The first stars appeared, and then later on these stars, they combined together to form the early galaxies, and slowly afterwards we had the formation of our own solar system. And that is how the universe occurred or the universe originated. Now, this expansion of matter, they form galaxies, and now this theory has been proved by the discovery of cosmic microwave background radiation, CMBR. What is CMBR? It is the radiation, the remnant radiation that occurred or that was left behind by this vast explosion. So this cosmic microwave background radiation, and also later on we had Wilkinson microwave anisotropy probe. So all these confirmed that the Big Bang occurred and the universe is right now expanding. Universe is in expansion. All right. So this is how the universe originated. This is how the origination of the universe occurred. We had the inflation. The quarks were formed after the explosion. Then first particles, the neutrons, protons, and dark matter that emerged or that were formed. What is dark matter? That we do not know exactly, but we can infer that there is certain matter that is there. So that is dark matter. Then there was helium was produced, hydrogen was produced, and then later on we had the stars, galaxies, and the solar system that were produced. Today, the universe, it continues to expand. So over here, you can see how this happened about 15 billion years ago, or to be exact, 13.8 billion years ago. That is the age of the universe. If somebody asks you what is the age of the universe, when our universe was formed, so it is 13.8 billion years ago. All right. All right. So this is the Big Bang theory. Now, when we talk about the universe, so based on the certain recent observations that we had, now we know that the age of the universe is 13.8 billion years ago. All right, especially after the Planck's observation was made. Now we have the age of the universe, that is 13.8 billion years. Now, this universe is composed of, or it comprises, three different matter and the energy. The complete universe, in the complete universe, we just know about 5% of the universe. Just about 5% we have visible matter. Visible matter that can be seen. All right. So it is basically the stars, the meteors, we have the different galaxies that can be seen or that is visible. So they comprises just about 5%, or to be exact 4.9% of the complete universe, which have hydrogen, helium, and other elements which are associated. Then comes dark matter. Dark matter, like I said, it cannot be seen visibly or even on the electromagnetic spectrum, but it can only be inferred that there is certain point or certain certain things which are there at that particular place in the in that particular environment or in that particular space. So it can only be inferred on the basis of gravitation, temperature distribution, and also orbital or rotational speed of the galaxies and the missing masses, just like black holes. So we cannot see black holes, but yes, the black holes can be inferred. So that comprises the dark matter. It is about 27%, or to be exact, to 26.8% of the universe. Now, I told you that the universe is expanding. The universe is expanding. It is slowly and slowly getting expanded. So there is a speed to this. All right. And this speed was calculated and then it was named as Hubble's constant. What is Hubble's constant? It is the actual speed that should have been there of this expansion of the universe. However, when this speed was calculated in actual way, so the speed of or the expansion of this universe is now getting accelerated, or it is much more than the Hubble's constant. So, for this, there has to be a certain form of energy that should be deriving force behind this accelerated expansion of the universe, right? So, this form of energy is not known to us, and it is the dark energy. Dark energy is 68.3% of the universe, and it is the matter, form of that matter, that is responsible for accelerated expansion of our universe. Now, when we talk about the evidences for the Big Bang theory, so we talk about Doppler shift or the Doppler effect, red shift and blue shift, and we also have now the evidences of the cosmological microwave background radiation and also the gravitational waves. So all these three together, they give us the evidence for that the Big Bang has actually happened, or it has actually occurred. And that is why it is now the most acceptable theory. When we talk about the acceptable theory or the most accepted theory of the origin of the universe, so that is the Big Bang theory. Now, what is Doppler shift or Doppler effect? You must have heard this, or you must have read this in physics. All right. So, what is Doppler effect or Doppler shift that is there? So, you must have, you must remember that there was an example in the NCERT books. There was an example in the NCERT books of the train coming near to a person. So what happens is, as the train is coming near and it is giving out a horn, all right, it is blowing horn. So what happens is, as the train is far away, you actually hear very feeble noise, or a very feeble sound of that horn coming towards you. But as the train approaches, the sound, it is increasing. The sound keeps on increasing, and you feel that these, what is happening? You feel that the sound is getting slowly and slowly increasing as the train is approaching you. So that is the Doppler shift. Actually, there is no change in the frequency. The frequency remains same of the horn, but because it is approaching you, so what happens is that you feel that there is a shift in the shrieking, or you can say that the amount of the sound or the loudness of the sound, it increases. So that is Doppler effect. Now, the same Doppler effect can be seen in the universe as well, because as a star will be approaching a person, or a star will be coming near to the earth, what will happen is that the wavelength will change, and the wavelength will change towards blue. Please remember this, that the wavelength will change towards blue shift. There will be a blue shift when a star will come near to the observer. So this is very important. Most of the students, they actually, if this is asked in the examination, they mark it wrong. And why they mark it wrong is because they have a common sense. See, what happens is, they will use their common sense and they will just, visualize a star coming near. So star, it will be giving off heat. So as it will be coming near, it will look red. So there will be red shift. And by using this logic, they mark that if the star is approaching an observer, they mark it as a red shift. But it is actually not red shift, but it is blue shift. Because when the object is moving closer, or the star, what is object here? We have star. When a star moves closer to an observer, what happens is that the Doppler shift occurs and the frequency shift towards higher frequency or the lower wavelength. Now, blue has a lower wavelength. So actually the wavelength gets shorter, and because the wavelength gets shorter, it changes towards blue. So we have a blue shift, and this is what we call as blue shift. So blue shift will happen when the star is moving closer. It will not be redshift. Please remember this. It is very, very important, and most of the students, they make this mistake. All right. So it is because of the wavelength that you will see the color or the wavelength, it will change towards blue, and that is what we call as blue shift. This is blue shift. And the vice versa is the red shift. That is when the object is moving away, when it moves away from the observer. So what happens is that the frequency becomes low or the wavelength gets longer. The wavelength gets longer, and ultimately when the wavelength gets longer, it changes towards red, and this is called as red shift. So red shift happens when the star is moving away. Blue shift happens when the star is moving towards us. Now, I have told you that the universe is expanding. Now, I want you to write the answer. I told you that the first evidence that we see is the Doppler effect. We see is the red shift and the blue shift. All right. So now write down in the chat box and tell me which shift you will see when the expansion of the universe will be happening. Tell me. If I am saying that the universe is expanding, which shift you will see? Whether it will be red shift or it will be blue shift. Yes, it will be red shift. Very good, Sonali and Raj. All right. Very good, Ritik Singh. All right. It will be red shift because the universe is expanding. So the stars are moving away from each other. As the stars are moving away from each other, so we will have red shift. Very good. Very good. All right. Now, coming back. So this is how blue shift and red shift they occur. The other things are cosmic microwave background radiation. Like I told you that when we are talking about cosmic microwave background radiation, they are also called as relic radiation. So, you know what happened was that with the radio telescope, we can see a faint background glow. All right, and it is basically in the microwave region. We have different spectrum. We have microwave, we have also ultraviolet, we have the infrared spectrum. So in the microwave spectrum, we see that faint light in the space when we are using the radio telescope. And this is why it is called as cosmic microwave background radiation. All right, so they are the oldest, or it is the oldest light of the universe, and it is found in all the direction. So it gives us this this theory that the earth or the complete universe, it originated from the Big Bang. So we have this cosmic microwave background radiation as well, and it can be seen using the radio telescopes. So with the radio telescopes in the microwave, spectrum, this background radiation can be seen. Now, coming to gravitational waves. The gravitational waves, they were suggested by Einstein. All right, it was the Einstein who suggested that we have the gravitational waves. Later on, they were even seen. So gravitational waves, it was in 1916 when, Einstein gave his general theory of relativity. So he said that these waves are just like, as you are throwing a pebble in a pond. So as you see that when you throw a pebble in the pond, what happens is that the waves are generated. In the same way, he said that these gravitational waves are there and they are generated whenever we have any kind of, disruption in the space-time that happens. And that is, these gravitational waves they were seen, and they also give us the evidence that the Big Bang happened 13.8 billion years ago, leading to formation of our universe. All right. Apart from Big Bang theory, there are other several theories which were propounded or given for the origin of the universe or how our universe came into being. One such theory is steady state theory. It was given by or proposed by Hermann Bondi, Thomas Gold, and Fred Hoyle. So they propose that, as we are saying that as per the Big Bang theory, what is happening is the universe is expanding. So we have only a particular area or region which we can see, that is called as cosmic horizon. Only up to that particular level you can see the space or you can see the universe. So that is called as cosmic horizon. So if the universe is expanding and if my field is only this much, if the universe is expanding, what will happen is that the galaxies and the stars, they will cross that cosmic horizon and they will vanish from my cosmic field, right? But so when this Big Bang will, or according to this Big Bang, what should have been happening is that the galaxies and the stars, they should be coming or they should be getting less day by day. However, steady state theory proposed the alternative. It says that the counting of the galaxies remains constant. So as the old galaxies, they are crossing the cosmic horizon, newer galaxies are getting formed or they are continuously forming and they are filling these spaces. However, the older galaxies, they are crossing the boundary lines of the observable universe or the cosmic horizon, and thus the number of the galaxies remains constant, and if it is constant, it gives the name steady state theory. The next theory is pulsating theory. The pulsating theory was proposed by Einstein, Richard C. Tolman, and Friedman. They said that what happens is, or what happened was that we had a Big Bang. There was a single atom, primordial atom. That primordial atom swelled and then there was a vast explosion. After vast explosion, what happened? The universe is currently expanding. Now this expanding universe gets its energy from the heat generated during the expansion, right? Because for any kind of motion, there would be energy that will be required. So it is getting its energy from where? This expansion of or expanding universe gets its energy from the Big Bang, that Big Bang that occurred. However, this energy will get exhausted one day. This energy will get exhausted one day, right? Because there is a theory or there is a law that says that the energy cannot be created nor be destroyed. Energy cannot be created nor be destroyed, but it can change from one form to another. Now this energy, this thermal energy or heat energy is getting changed into kinetic energy, and that is why our universe is expanding. So at a particular period of time, when this heat energy will dissipate, now what will happen is that there will be no driving energy. Now what will happen is that there would be a new energy or new force that will be, or rather I will say this force is old, but this force will start acting, and this force, what we know is the gravitational force. So as the gravitational force will start acting on the cosmic bodies, what will happen is they will start contracting. Now they are expanding. The universe is expanding. So what is happening right now? Because of that energy, universe is expanding. And at one point of time, what will happen is that when this energy gets exhausted, the gravitational force will come into role play and it will start attracting all the cosmic bodies together. And again, it will form a primordial atom. And again, there would be a Big Bang. Again, there would be expansion. And this will go on. So at present, universe is expanding. After some time, this expansion will stop, and due to gravity, what will happen is that the contraction will begin. And again, this contraction will lead to, or it will occur up to a point when the energy generated by contraction, it will lead to again a newer explosion. So there would be expansion right now, then contraction, then again explosion, again expansion, again contraction. And since this is repeating itself, therefore, it was called as, or it was known as the pulsating theory. However, pulsating theory or steady state theory, they are not considered or they are not exactly regarded as the theory of the origin of the universe. Like I said, the most acceptable theory is Big Bang theory. All right. Now, like I said, the age of the universe has been estimated between 12 to 14 billion years ago. And the scientists, they estimate that the age of the universe is 13.8 billion years ago. All right. On the basis of, would be 13.8. So it is 13.8 billion years ago. And this measurement was made after measuring the cosmic microwave background radiation. However, our solar system is quite new. It is just 4.5 billion years ago. There would be a big crunch. This big crunch will happen. Like I said, there is Hubble's constant. Hubble constant is the speed of the expanding universe. What is Hubble constant? It is denoted by HO. HO or Hubble's constant. So Hubble constant is nothing but it is the speed of expansion. So the rate of expansion or speed of expansion is measured as Hubble constant. Now, if the density of the universe, it is greater than critical density. What is critical density? It is proportional to Hubble constant. So suppose this is critical density. Critical density is proportional to Hubble constant, all right, and its square. Now, if the density, we can say rho is density. If the density of the universe is greater than this critical density, what will happen is that the universe, it will start contracting or the gravity will be very, very large and the universe will collapse on itself. This is called as a big crunch. This is known as big crunch. All right, when the universe will collapse on itself. All right, clear everyone? Is it clear to everyone? How the universe originated, also Big Bang theory, the steady state and the pulsating theory. Any doubts up till now? All right, very good. Raj, Ritik and Sonali. Now, what are galaxies? Galaxies are nothing, but they are collection of stars. The different stars, or along with stars, we have the dust, gases and dark matter that is bound together, that is called as galaxies. Now, the galaxy may be an island universe as well. Certain galaxies are called island universe. Please do not get confused with the term universe, because over here island universe means the vast galaxies, the big galaxies, the bigger galaxies are called as the island universe. There are various or billions of galaxies in the universe and they have different size, shape and structure. The galaxies, they could be irregular. Irregular are the young galaxies. As they are young, they do not have a particular shape. So they are called as irregular galaxies. Then they become mature. As they become mature, they acquire the shape of a spiral with central mass and the rotating, arms outside. There is a disk in between and the rotating arms that are there outside, that is the mature phase of the galaxies. And then we have the older galaxies. The old galaxies would be found in a elliptical shape. So we have prominently three shapes: irregular, spiral and elliptical. We have more of the galaxies which are mature or they are spiral. We have 80% of the galaxies which are spiral, like our M101 or even our galaxy, that is Milky Way. Milky Way galaxy is also a spiral galaxy, or even Andromeda galaxy is a spiral galaxy. So we have spiral galaxies, mature galaxies which are more in the universe. Then when we are talking about the young galaxies or the irregular galaxies, there are only 2% of the galaxies which are new galaxies, and the rest, about 18%, are the old galaxies or the elliptical galaxies like ESO 325G004. So this is how our Milky Way is there, or it looks like. You can see over here, we have satellite galaxies as well. All right, we have faint stellar halo. Stellar halo is like a circle which is illuminated by the stars. Then we have solar neighborhood, where we have our solar system that is there, and it is there in this arm of the Milky Way, and this arm is actually called as the Aravat Path. Aravat Path is the place where our solar system is there. So this is how our Milky Way it looks like. We have about 200 billion stars in our Milky Way galaxy, and it is also a spiral galaxy. Now let's talk about the generation or the life cycle of a star. As we grow old, so we move through different life cycles. We get born. After the birth, we get mature, then we get old, and then we die. In the same manner, the stars also have a life cycle. They also get born. Later on, after getting born, what happens is that they mature, and later on, they also die. The stars are formed by the nebula or from the nebula. What is a nebula? Nebula is nothing but it is the cloud of gases and dust particles. The cloud of gas and dust particle. Gases, majorly hydrogen and helium are there, and dust particles. So that is called as the star forming nebula. Like we have Eagle Nebula. Now what happens is, if this nebula will be large, so it will collapse under the gravity, and there would be the born of or the birth of the star. It will be called as protostar. It is the newly formed star. A newly formed star is called as protostar. However, if the mass is not huge of the nebula, the nuclear fusion will not be prominent, or the nuclear fusion will not be of a large scale. So what will happen? If the star forming nebula is not of considerable size, it will change into red dwarf. Protostar will not be formed, red dwarf will be formed, because there will be lesser or less fusion. So due to less fusion, the star will not be as bright as it should have been, and red dwarf, it will look like a red because of the low fusion that is happening, and also the size is small, so it will be a dwarf star like Proxima Centauri. In our Milky Way, maximum or more of the stars are dwarf or red dwarf stars. Then slowly and slowly, as the fusion dies, it becomes blue star or blue dwarf, and when the nuclear fusion stops, it becomes white, and then later on it becomes black dwarf, that is, it becomes dead. This is dead star or black dwarf. However, if the mass of the solar forming or the star forming nebula is great, or it is of considerable size, so what will happen is that because of this, the protostar will be formed, the nuclear fusion will start, and after the nuclear fusion, it will become either a mid-sized star or a massive star, depending upon the mass of this protostar. Now, the mid-sized star, just like our sun, then it will what will happen is that the nuclear fusion is there. So because of the nuclear fusion, what is happening is the lighter elements converts into lighter elements, they gets converted into heavy elements. So as the heavy elements are getting formed because of the nuclear fusion, so what will happen? That the star will swell in size. It will become large. It will enlarge in size. At the same time, when the hydrogen is getting diminished, the rate of nuclear fusion will also get decreased, and the star which is looking like a bright yellow star, it will slowly and slowly start changing its color to red. So when it becomes giant, it becomes giant because the heavier elements are getting formed from the lighter elements due to nuclear fusion. And it becomes red because of the depleting hydrogen, like Arcturus. Later on, what happens is that there is still nuclear fusion stops in the outer layer. What happens is that the nuclear fusion that is happening, so nuclear fusion stops in outer layer, but it continues inside the core. So you must have seen during Diwali season, what we do is that we use certain cartons and then we ignite a cracker inside it. Alright, we ignite a cracker, we put the carton on the top of the cracker. What happens is when the cracker explodes, the shell or the carton also explodes. Now, this happens because there is pressure inside it. So now the core is still active. Core is active. Nuclear fusion has stopped in the outer layers, but not in the core. So core is still active. So what will happen? That will create a pressure on the outer layers. And when that pressure will be tremendous, what will happen is there would be an explosion. There would be an explosion, and this explosion is called as nova explosion. So there would be a nova explosion, and after this nova explosion, the outer layers, they will get dispersed, or the outer layers, they will change into back into the dust particles and gases, and that will form the nebula. Again, what is nebula? The cloud of dust and gas particles. So the outer layers, they will form the nebula, and the core will remain. This core, again, as the nuclear fusion will stop at the later stage, the star will become white dwarf, and then it will become red dwarf. Sorry, black dwarf, and then white dwarf, and then black dwarf. All right. Now, the same thing happens for the massive stars as well. However, for the massive stars, the thing is that everything is in much more, or you can say the intensity is more, because of course the star is massive, or it is high mass star like Spica. Now, what happens is that instead of red giant, this massive star changes into red supergiant. It will be very, very large red supergiant that will be formed like Betelgeuse. And instead of the nova explosion, there would be supernova explosion. After the supernova explosion, the core will remain. All right? Only core remains. And the rest of the star, it disperses in the form of gases and dust particles. Now, what will happen to this core? It depends on the mass of the core. All right. Now, this mass is very, very important. The mass of this core is very, very important. Why it is important? Because this mass will determine the future of this particular core. There is a limit that is called as Chandrasekhar limit. CSL or Chandrasekhar limit, it is equal to 1.44 times mass of our sun. Chandrasekhar limit. It was calculated by Chandrasekhar Subramaniam, and that is why it is called as Chandrasekhar limit, CSL. Now, if that mass of the star, of the core, if this mass is less than Chandrasekhar limit, then this core will change into neutron star. And if the mass will be greater than Chandrasekhar limit, then what will happen? The star or the core, it will convert into black hole. And that is why Chandrasekhar limit is very important. So that is how white dwarf, neutron star and black hole, they are formed. Basically, white dwarf neutron star and the black hole, they are the dead stars. They are what? They are nothing but they are the dead star, or it is the last final phase of the star, the death of the star. So in white dwarf, what happens? The electrons, they run out of the room to move around the nuclei, and then they are forced into lowest energy quantum states, and that creates the white dwarf. In neutron star, the protons are forced to absorb electrons, and then they are converted into neutrons, and these neutrons, when they are together, that form neutron star. And when the neutrons also completely collapse due to gravitational force, and even the light cannot escape. The gravity is so much that the light can also not escape from that particular place. Then it is called as a black hole. So this is the Chandrasekhar limit. Like I said, it is 1.44 times that of the mass of the star. It was calculated by Subramaniam Chandrasekhar. Now, when the stars, you must have seen in the night sky, certain stars, they appear to form certain shapes. Now, these shapes were very important during the ancient period of time, or even right now also. If you are a trekker and you get lost in jungles, you get lost in the wilderness. So, with the help of these constellations, you can find out the directions. All right, depending upon the season of that particular, the year, which season you are, trekking in or you are lost. So, on that basis, you will find that there are different stars that could be seen in the sky, and those stars form different shapes. So with these, the Big Dipper or Saptarishi that we call, so that if you can locate that constellation, you can easily find the pole star that always points towards the North Pole, and with that you can always navigate. There are in total 88 constellations that are recognized. We have total how many constellations? 88 constellations are recognized. All right. Now, let's talk about the solar system. When we are talking about the solar system, it is nothing but it is the sun's family. All right. It is the family of the sun. So what comprises the family of the sun? Of course, we have sun, which is the star, all right, and it is source of nearly all the, it is a star, and it is responsible for all the kind of energy that we see on the earth. Then we have planets. We have total 8 planets which are there. We have planets which are part of the solar system. Then with planets, we have satellites as well. So with planets, along with this, we have satellites of the different planets that are there. Along with this, we have asteroid belt. You can see that this asteroid belt is located between, or asteroids are located between Mars and Jupiter. So we have asteroids which are part of the solar system. We have comets which are part of the solar system. All right, which generates from the Kuiper belt. We have all these which are part of the solar system along with dust and gas particles. We have dust and gas particles as well in between. So all these comprises of the solar system. Now, how this solar system originated? So there were various theories which were propounded regarding the origin of our solar system. Now, you do not have to go deeper into these theories. All right, you do not have to go deeper into these theories. These theories, you just have to remember the propounder name, because sometimes in some of the examination, like for the PCS examination, you may find that match the following type of question has been asked. All right, so you do not have to go deeper into them. These are the different hypotheses which were propounded, like gaseous or nebula hypothesis was given by Kent and Laplace. Then there was planetesimal hypothesis given by Chamberlain and Moulton. Tidal hypothesis by Sir James Jeffreys and Harold Jeffreys, binary star hypothesis by H.N. Russell, supernova hypothesis by Fred Hoyle, interstellar dust hypothesis by Otto Smith, electromagnetic hypothesis by H. Elfven, and protoplanet hypothesis by Kuiper, and nebular cloud hypothesis by Dr. von Weizsäcker. Out of these, the most prominent one is the gaseous or the nebular hypothesis, because it is the most, you know, you can say it is most accepted theory of the origin of the solar system. Now, like I said, that the solar system is majorly dominated by the sun. We have sun, which contributes 99.99% of the complete mass of our solar system. Sun is at the center, and then we have 8 planets. We have their satellites as well as dwarf planets which are there, asteroids, meteors, as well as comets, which make up the solar system. So that is the solar system that we have. Okay. Now, coming to the sun, sun is yellow dwarf star. Our sun is the yellow dwarf star. It is a low mass star and it was formed 5 billion years ago. It was formed 5 billion years ago. It is the nearest star from the earth. Nearest star from the earth, it is about 150 million kilometers away. This is the average distance between earth and star, and it is also called as astronomical unit. It is called as astronomical unit, and it is used for measuring the distances in the space. It is source for almost all the energy. We have major gases in the stars, that is hydrogen and helium. The surface temperature is 5500 Celsius and the core temperature is 1 crore 56 lakh Celsius or 1.57 million Kelvin. For its revolution, it takes 224 million years. So over here we have our galaxy, that is Milky Way. So from Milky Way, what happens is that the Milky Way is rotating around itself. So Milky Way is rotating around itself, and in the same manner we have sun and our solar system somewhere here. All right, this is our sun. So what happens is when the Milky Way is rotating, so along with this rotation, our sun also completes one of the revolution, and that is called as the cosmic year. It is 224 million years. Then we have rotation. Since sun is a gaseous giant, sun is what? It is made of or comprised of the gases, majorly hydrogen and helium. So the rotation is not uniform. Rotation takes 25 days at the equator and 36 days at the poles. Now, the temperature of the sun is quite high. It is 5500 Celsius at the core, at the surface. All right. And at the core, it ranges to 1 crore 56 lakh Celsius. So, obviously, it is not possible for us to go to the sun's surface and to know about the different elements which are present there. So, what happens is that we have white light. White light, on the white light of the sun, we have superimposed dark lines. There are 100 of dark lines which are superimposed, and these dark lines are called as Fraunhofer lines. These lines let us know about the different elements which are present on the surface of the sun. The different elements which are present on the surface of the sun, we come to know about them through the Fraunhofer lines. All right. Now, here you can see that we have the different zones or different layers of the sun as well. Okay, we have different layers of the sun. So when we are talking about the different layers of the sun, they could be divided into internal as well as the surface layers. So when we are talking about the internal layers, so in the internal layers, we have these 3 layers. They are the internal layers. So we have core, that is the innermost layer. Then we have radiative zone. Radiative zone is the intermediate layer or the second layer above core, and then we have the convective zone, that is the topmost layer in the internal layers. All right. Then there is techoline as well. That is a kind of, you can say, between the core and the, between the radiative zone and the convective zone. Now, these are the internal layers. At the same time, we have the surface layers as well. In the surface layers, when you talk about, the first layer is the photosphere. We have the photosphere that is there. Then we have chromosphere as well as corona. So these three layers are on the surface of the sun. Corona is only visible during solar eclipse. It can be seen only during the solar eclipse, corona. Otherwise, it is not visible. And at the same time, photosphere and chromosphere, they are the, the chromosphere is the visible layer of the sun that you see. Okay. Now, when we are talking about the solar phenomena, the different phenomena that is visible on the sun surface. These different phenomena, like we have solar wind. Solar wind is nothing but they are the charged particles. The charged particles, when they leave the surface of the sun, they become the solar wind. This solar wind or the charged particles, when they combine with, or these are, what they do is they combine, or you can say they meet. When they meet magnetosphere of the earth, when they meet magnetosphere of the earth, what happens is we have auroras. We have auroras. What are auroras? They are also called as polar lights, northern lights or southern lights. So auroras are basically colorful display of the light that you see in the polar regions and at certain other places of the earth as well. Like for example, in Leh, you can see those auroras as well. So when this solar wind, it combines with the magnetosphere of the earth, what happens is they are charged particles. We have magnetic field that is there. When both of them they combine, it lays down the colorful displays in the sky, and that is called as aurora. It is known as aurora borealis. Aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere, or the northern and the southern lights. All right. Then there are sunspots as well. The sunspots are basically the regions of low temperature. They are what? They are regions of low temperature. They are called as, on the surface of the sun, they are called as sunspot. Now, along the sides of the sunspot, you will find the plages. So, we have sunspot and plages, they occur in pair. So, the regions of the low temperature, that is called as sunspot. At the same time, we have the regions of high temperature. Along with them, we have regions of high temperature. So the regions of high temperature along with or alongside with sunspot, they are called as plages. We have plages which will be there along with sunspot. Now, sunspot is a phenomena that takes about 11 years cycle. For the 11 years, it will go on increasing, then it will decrease. All right. There is a waxing and waning phase. So the sunspot, they increase and then they decrease. The sunspot is very important because if the sunspot is maximum and the Earth's magnetosphere is weakened, what will happen is that the magnetic poles will get reversed. So sunspot phenomena is also important for the magnetic reversal of the poles of Earth. All right. Then we have also flares. Solar flares are there. They are just like, bouts of heat that is coming out from the surface of the sun. Again, they will contain the charged particle. We have prominences as well, which you will see, as well as you will see the coronal mass ejection. So from the corona, if you see the mass of the electron and protons which ejects, so that is called as coronal mass ejection as well. So we have all these different things or different phenomena that you will find on the surface of the sun as well. Now, along with the sun, we have planets which forms the solar system. The term planet has been derived from the Greek word planetai. Planetai means wanderer. And these wanderer or the planets, they revolve around the sun, that we call as revolution. So all the planets will have a revolution of their own. All right. They will be revolving around the sun in the elliptical path, which is known as the orbit. And also there would be another movement of the planets, that is rotation. They will be moving around their own axis. So that is called as rotation. The planets have their no light or the heat, and they could be classified into two different ways: inner or the terrestrial planets. They are called as inner because they are the innermost, they are closer to the sun, and they are called terrestrial because they have solid crust, just like we have on Earth. So they have solid crust, and that is why they are called as terrestrial. Like we have the first four planets: Mercury, Venus, Earth, and Mars. They are classified as inner or terrestrial. Then we have outer or the Jovian planet, or they are also called as gaseous planet because they are gaseous giants. They are called as Jovian. Jovian means Jupiter-like. Jovian means Jupiter-like. So they are Jupiter-like or gaseous giant, or they are the outer planets. And we have again last four planets which are classified as outer or Jovian or gaseous planets. We have Jupiter, Saturn, Uranus, and Neptune. So we have all these planets which have been arranged over here, that you can see over here. All right, so we have the first planet, that is Mercury. We have Mercury. Then we have Venus. Then we have Earth. And we have Mars. So they are the inner planet. They are inner planet or they are terrestrial planet. Then we have Jupiter. We have Jupiter. Then we have Saturn, Uranus, and then we have Neptune. All right. Now, in your examination, the question may come into arranging them from, going away from the sun or towards the sun. It may be asked, or on the basis of the size. Now, when we are talking about on the basis of the size, so on the basis of size, it is Jupiter, Saturn, Uranus, and Neptune. All right, they are the biggest ones in the same order. All right, so we have the biggest one, Jupiter, then we have Saturn, then we have Uranus, and then we have Neptune. Then comes our Earth. Then comes our Earth at 5th position. Then comes Venus, and then Mars, and then Mercury. All right. So in both ways, the question can be asked that arrange them on the basis of their distance from the sun or on the basis of their size. So you have to remember both of them. All right. Now, till 2006, or to be exact, 24th August 2006, Pluto was also a planet. However, on this day, the International Astronomical Union gave a definition. It gave a definition about the celestial objects and said that a planet will be some celestial object which will satisfy all the three conditions. The first condition is that it is in orbit around the sun. Second is that it has sufficient mass so that it has acquired the hydrostatic equilibrium or a nearly round shape. The third is that it has cleared the neighborhood around its orbit. Now, Pluto has not cleared the neighborhood. That is why Pluto was later on shifted to dwarf category or the dwarf planets. Now, we have on 24th August 2006, there were three conditions that were laid. So, any celestial object which satisfies all three conditions, it will be termed as a planet. However, if only first two conditions are met, if only first two conditions are met. What are first two conditions? That it is in orbit around the sun, has a sufficient mass to acquire the hydrostatic equilibrium, then it will be called or termed as dwarf planet. It will be termed as a dwarf planet like Pluto, Ceres, Eris, Makemake and Haumea. So there are 5 dwarf planets right now in our solar system. Then if a celestial object satisfies only first condition, it just satisfies first condition, that is it is in orbit around the sun, then it will be called as SSSB, triple SB, that is small solar system body. And in this, we will have two solar system bodies. We will have comets, which are around, they are in orbit around the sun. And also, we have the asteroids, comets, and we have asteroids. All right. So they are small solar system body because they just satisfy the first condition and not the rest of them. Now, let's talk about the different planets that are there. We have the first planet, that is Mercury. The name was given on the god of speed, Roman god of speed, Mercury. It is the nearest and the smallest planet to the sun and also has a cratered surface. Cratered surface, that means it has lots of depressions on the surface, just like we have on moon. So this is Mercury, not moon. All right, it has maximum diurnal range of temperature. Now, diurnal means daily. Range means maximum minus minimum. So daily, the difference between maximum and minimum temperature is very large. That is the diurnal range of temperature. The daytime, it ranges at around 430 degrees Celsius and the night time is minus 180 degrees Celsius. So the range is somewhere where 600 and something it will come up. All right. How many? It will be 610 degrees, right? Because 430 minus and minus 180. So it will become plus. So 430 plus 180. It will be 610 degrees Celsius. That is the range of temperature. Now, my question is, where on the earth you will find the maximum diurnal range of temperature? Answer me. Just a wild guess. Answer me in chat. All right, tell me where on the earth you will find maximum diurnal range of temperature. No, of course it will be on land. But where? Where on land? Have you heard that if you are going to deserts, have you heard that you should pack you should pack quilts as well, because in the night time in the deserts the temperature will be very less. We'll have to use blankets, all right, in the deserts. So where on the earth you will find maximum diurnal range of temperature? In deserts, all right. So deserts have the maximum diurnal range of temperature. The daily day temperature will be very high, but at the same time the night temperature will be very low, and that is why you will find maximum diurnal range of temperature in deserts, all right. Now, Mercury has no atmosphere. It has no atmosphere. However, the exosphere or the outer atmosphere is comprised of very thin layers of gases, mostly oxygen, sodium, hydrogen, helium, and potassium. Since Mercury is closest, it will have revolution that is fastest. It just takes 88 days to complete a complete circle around the sun. And the rotation is 59 days. Mercury has no satellites. Then comes Venus. Venus is named after Roman goddess of love. That is why it is said that men are from Mars and women are from Venus, right? So, it is named after Roman goddess of love. It's also called as Earth's twin planet because it resembles Earth in shape and size. It is the hottest planet. Please remember, it is not the Mercury, but it is the Venus which is the hottest planet. Why? Because atmosphere consists mainly of carbon dioxide. Now, carbon dioxide is what? It is a greenhouse gas. It is what? It is a greenhouse gas. Now, what is the property of greenhouse gas? The greenhouse gas, they absorb long wavelengths. They absorb long wavelengths. And because of this, why Mercury is not the hottest planet? Because Mercury has -degree temperature during night time. But Venus do not have -degree temperature during night time because of the carbon dioxide. Because the carbon dioxide traps the heat in the atmosphere. And that is why Venus is the hottest planet of the solar system. It is also the brightest object after sun and the moon. It is the brightest object. Why again? It is brightest object because of the highest albedo. Highest albedo because we have the clouds of sulfuric acid in its exosphere, about 45 to 70 kilometers, and they reflect the sunlight. So now there is a different term that we have came across today, that is albedo. What is albedo or what is meant by albedo? Albedo is nothing but it is simple. It is the amount of sunlight reflected without absorption. That means the surface is not absorbing it and it is simply reflecting it back. That is called as the albedo of any place or anything. So now my question is where on earth you will find the highest albedo? Where on earth you will find highest albedo? Yes, ice and glaciers. Yes, very good. Very good. Raj, Ritik, very good. Snow, not in deserts, but it will be in snow, in the poles. Yes, where you will find the ice. So the ice or the snow that has the highest albedo. That is why you must have seen that when our army jawans and the officers, they are there in the Siachen. In the Siachen glacier, you must have seen that they wear heavy goggles. Why? Because it is, when the sunlight is striking the glacier or the snow, when it gets reflected back, it is as equal to watching the sun directly naked with the eyes. Because 90% to 95% of the sunlight is reflected by the snow. All right. So that is why they wear heavy goggles. Now, there is also phosphine that is found in the or that was observed in the clouds of the Venus. It is possible indicator of the microbial life, however, not completely. Venus is also known as morning or evening star because you can see Venus in the sky just in the evening before it gets completely dark. You can see it, or just before the sunrise. Also, it rotates from east to west, that is in the opposite direction, and it takes 243 days to make a complete rotation. It is the slowest in the complete solar system. Always remember, we have two planets which ends in us. We have two planets which end in us, that is Venus and Uranus. So, always remember that the planets which ends with US, that planets, both the planets, they have opposite rotation. They rotate from east to west. The revolution is 225 days. The next comes the third planet, that is our Earth. When we talk about our Earth, the shape of the Earth is geoid. Geoid means Earth-like shape, or you can say it is oblate spheroid. It is oblate spheroid. Now, what is oblate spheroid or geoid-like shape? So, just take one ball in your hands and place it like this, with your hands on top and in bottom, and then press that ball a bit. When you press that ball a bit, so what will happen? It will enlarge from the middle, and the poles will get flattened. So that is the shape of the Earth. It is not completely spherical. It is not completely spherical. It is oblate spheroid. It is flattened from the poles and enlarged from the equator. We have about 70% of the Earth that is water, and that is why Earth is known as blue planet, and it is the only planet where we know about the existence of the life. When there are, space explorations, in space explorations, generally we see or we try to see such kind of places where, a considerable distance from the star is there. Because if there will be a considerable distance, see, any object or any planet, it should not be closely placed towards the star, because if it is closely placed, then the temperature will be quite high. Then it should not also be placed far away from the star, because if it is placed far away from the star, again the temperature will be very low for the existence of the life. So there is a right distance from the sun where the existence of the life can occur, and this distance is known as Goldilocks zone. So sometimes you must have heard this term Goldilocks zone, or you must have read this term in newspaper, that a particular object has been found in the Goldilocks zone. So what is Goldilocks zone? It is neither too far, neither too close to the star, and there could be possibility of the existence of life, or life could exist on that particular place. Our Earth is the densest planet of all. Its average density is 5.52 gram per centimeter cube. Although the density, it goes on, increasing as we move towards the core of the Earth. However, the average density is 5.52 gram per centimeter cube. Our atmosphere consists mainly of nitrogen and oxygen. For revolution, it takes about 365 days. For rotation, 24 hours. And we have only one natural satellite, that is Moon. Now, how the Moon was formed? How the Moon came into existence? How the Moon came into existence? So it was actually Hartmann and Davis. Hartmann and Davis, they propounded our theory. All right. They propounded a theory, or they said that the Moon came into existence because of a giant impact. This theory is known as giant impact theory, right? Yes, big splat or giant impact. So we usually call it a giant impact theory. So what happened during giant impact was that there was a planet named Theia. So it is propounded that Theia, it came near to the Earth during the formative years when the Earth was getting formed. So during that period of time, this Theia came close to Earth and then there was an impact or a big splat. This Theia, although it did not destructed Earth. So there was just, it just from the side, it, brushed, and a matter was fallen outside known as big splat. So this big splat resulted into throwing of the matter from the surface of the earth outside, and this matter slowly and slowly it started circling the earth's due to gravity, and ultimately when it got solidified, that led to the formation of the moon, that led to the formation of moon itself. All right, so this is how our moon was formed, or this is how the giant impact had worked. Okay. Now, coming to the next or the fourth planet, that is Mars, named after Roman god of war. It is called as red planet. It is known as red planet. Why? Because of the iron minerals which are found here. Iron oxide is there in the Martian soil. It oxidizes and then leaves a prominent red color. There are various dormant volcanoes which are found here, and one of that volcano is Olympus Mons, which is the highest mountain or volcano of the solar system. It is the highest mountain or volcano of the solar system, Olympus Mons. Its atmosphere comprises mainly of carbon dioxide, argon and nitrogen. Although small amount of oxygen and water vapor have also been traced here. Its revolution takes 687 days and rotation takes nearly the same amount of time as our Earth, that is 24.6 hours. There are two satellites, Phobos and Deimos. Please remember them. All right, Phobos and Deimos is the smallest of the solar system. It is the smallest satellite of the solar system. Then comes Jupiter, which is king of the Roman god. It is the largest planet of our solar system, and it is so large that 11 Earth can fit in its equator. It is third brightest object in the night sky after Moon and Venus. There are faint rings. Okay. Please remember that in the outer planets, all the outer planets have faint rings. Okay. And also it has a great red spot. You can see over here, over this, you can see this great red spot. Now, this great red spot is nothing but it is a cyclonic storm that is there on the surface of the Jupiter. There was a comet Shoemaker-Levy which struck the Jupiter and broke up in 1994. Its atmosphere comprises mainly of hydrogen and helium. There are clouds of methane and ammonia which are found in its outer region. The revolution takes 11 years and 11 months, and the rotation takes only 9 hours and 56 minutes. That is about 10 hours, and it is the fastest rotation of any planet. All right, it is the fastest. The satellites are 95 total satellites. We have 95 satellites. Like prominent one are Europa, Callisto, and Ganymede. And Ganymede is the largest satellite of our solar system. All right. Also, the Jupiter has the maximum number of satellites in the world, in the solar system. All right. Now, another thing is, had Jupiter been a bit larger, what would have happened? Jupiter would have converted itself into a red dwarf. Also, a point to be, remember is that Jupiter is one such planet which gives off more heat than it takes from the sun. It gives off more heat to the space than it takes from the sun. That is Jupiter. The next planet is Saturn, or Roman god of seed. It is second largest planet of our solar system, and also please remember it is the least dense among all planets. Its density is even less than 1 gram per centimeter cube. That means it is so dense that it can float on water. It can float on water because the density is I guess 0.7 or 0.9 gram per centimeter cube. So if any object has density less than 1, it can easily float on the water. It appears yellowish and is surrounded by rings which are made up of dust and ice particles. So it looks like a replica of the solar system. Along with the rings that are there, it looks like that it replicates the solar system. So it is replica, it is known as replica of solar system. For revolution, it takes 29.5 years, and for rotation, 10.7 hours. There are 63 confirmed satellites of Saturn. 20 are awaiting confirmation, and Titan is one prominent satellite of Saturn, which has an atmosphere just like that of our Earth. And there is possibility that the life can exist or life exists on Titan. There are various missions which have been sent to discover the same. The next planet is Uranus. Again, when we have Uranus, again we have US at the end. That means it also rotates from east to west. That is in the opposite direction. It is the first planet that was discovered with the help of the telescope and called green planet. It has a tilted axis of 98 degrees. So 98 degrees like this. We have this pen. You can see this pen. All right. So if it will be like this is 98 degrees. And now it is rotating like this. So because it looks like, all right, this planet, it is tilted 98 degrees and now it is rotating like this. So it looks like a lying planet. It is lying down. It is called as lying planet because of its excessive tilt. It is lying planet. It is also surrounded by faint rings and it is ice giant. We have lots of icy material which is made up of water, methane and ammonia, which is found in Uranus. Atmosphere again consists of hydrogen and helium. Revolution is 84 years and rotation is 17 hours. The satellites are 27 with Miranda, Ariel and Umbriel being the prominent ones. Last planet is Neptune. Neptune is named after Roman god of the sea. It contains blemish, which is called as great dark spot. Again, it is a cyclone that is on the surface of the Neptune. It also has a system of faint rings and appears bluish in color because of the methane. It was planet which was found by Urban Le Verrier and also John Diggle by mathematical prediction, and for the revolution it takes 165 years and for rotation it takes the 15.7 days. Of course, it is the last planet, so the revolution time period is the maximum. It is the maximum. There are 14 satellites. We have Triton, Nereid, which are the important ones, and because we have Pluto, I have told you, Pluto, what happens is Pluto is sometimes closer to the sun than Neptune is. Because when Pluto is near to sun and Neptune is far away, so of course Pluto will be close to the sun and the Neptune will be far away from the sun. Now, after this, after the planets, we also have the dwarf planet. Like I said, that these are the celestial objects which follow just the first two rules, which were given by the International Astronomical Union, and they are called as dwarf planet. We have 5 dwarf planets. We just have to remember their name. We have Pluto, Makemake, Haumea, Ceres, and Eris. So they are the 5 dwarf planet. Pluto, Makemake, Haumea, Ceres, and Eris. Then in the when we talk about the solar system, we also have small solar system bodies and as well as other celestial objects as well. Like for example, when we talk about this, we have comets. Comets are nothing but they are the mass of ice, as well as along with ice, there is dust particle rocks and they drift in the space. They have a tail. They have a tail and also, this tail or the comet, they grow or they glow when it comes near to the sun. All right, so it is only at that point of time that you can see the comets. The tail is made up of water and dust and they are vaporized by solar energy, and the tail will be always always away from the sun. We will see that the tail will be always away from the sun of the comets. Then come asteroid. I told you asteroids are what? They are basically again body of rocks and debris that is there, and they are located in the asteroid belt. Asteroid belt is between Mars and Jupiter. All right. And sometimes the asteroids also they become the comet nuclei as well. Then comes meteor or meteoroid. Meteor or meteoroids are basically the fragments or the rock materials which enter the Earth's space. When they enter the atmosphere, before entering they are called as meteoroid. When they enter the Earth's atmosphere, because of the gases and the friction, they start heating up and burning up. So during that point of time, they are called as meteor when they are burning. All right, when they are burning, it will be called as meteor. It will look like a shooting star. But when they occur in the cluster, they are called as the meteor shower. When a meteor reaches Earth, when it reaches Earth, it will be called as meteorite. When it reaches Earth, then it is called as meteorite. All right. And there are fireball also. They are the meteor that burns as they are traveling through the atmosphere. So they will leave a very bright streak of light behind. So this is basically when the meteoroid is very large or denser. So that point of time you will see a fireball. All right. And like I said, when the meteor is not completely burned up, so it travels and it reaches the Earth, and then it is known as the meteorite. So over here you can see our complete solar system. We have Sun, then Mercury, Venus, Earth and Mars, then we have Jupiter, then Saturn, Uranus, Neptune. All right, then we have heliopause, and this is called as heliosphere. Heliosphere is up to where you can find the solar wind. The solar wind or the charged particles coming out from the sun. This is basically heliosphere, and heliopause is the termination limit of the solar system. Then comes the interstellar space and the Oort cloud as well. It is the Oort cloud, and also here we have the Kuiper belt through which the comets originate. It is from here that the comets, they usually originate. All right, so this is heliopause and the heliosphere. Now, we have Kepler's law of the planetary motion as well. There are three laws of Kepler's planetary motion. The first law is law of orbit. Simply, it says that the planet, every planet which is around the sun, they will revolve around in an elliptical orbit. And the sun is located at one foci. It is the law of the orbit. It is the first law. The second law is law of area. It says that the line joining planet and the sun, it will sweep an equal area in equal interval of time. That is, the aerial velocity of planet will be constant. Now, on the basis of law of area, suppose we have two positions. You will answer me. All right. This is position A. This is position B. Now answer me where the planet's velocity will be high, at A or at B. Answer me in the chat box. Let me know in the chat box where the planet's velocity or its speed will be high, at A or at B. Tell me. Based on the law of area. All right, let me tell you. Now it says that the law of the area says that the sun or the planets, they will sweep equal area in equal interval of time. All right. Now on that basis, you see that the area will be, this is the area of the arc. And here the area will be this. Okay. Now on this basis, we can see that the area S1 and S2, that will be same. The area of S1 and S2, both the arcs. However, when we want to see the velocity, we'll be seeing this, only this length of the arc. We'll be seeing only this length of the arc. Now, on this basis of the diagram and on the basis of the area, you may note that length of arc B, length of arc B, it is less than arc A, right? Length of arc B will be shorter than length of arc A. So this is distance. Now what is speed? Speed is equals to distance upon time. Now T is constant. T is constant. In the same interval of time, in equal interval of time, what will happen? The area will be the same. That is law of area. So T is constant. Now speed is directly proportional to D, right? And length of arc A is more than length of arc B. So of course, what will happen is speed at A will be greater than speed at B. That gives us the result that the planets, the rotational speed or the rotational velocity of the planets will be more when they will be near to the sun as compared to when they will be far from the sun. Got my point? That the law of area, how it gives us that the speed will be more when we will have the planets which will be closer to the sun. At that point of time, they will move with a relatively higher speed, but when they will be away from the sun, the speed will get slowed down. Okay. And then we have the law of the period. Law of the period simply states that the square of the time period of the planets revolving around the sun is directly proportional to the cube of semi-major axis of the elliptical orbit of the planet, or T square is directly proportional to cube of semi-major axis. All right, so this is the third law of the Kepler. That means that a planet which will be closer to the sun will have the fastest revolution, and the planet that will be away from the sun will have the slowest revolution. So simply we have the fastest revolution of Mercury and the slowest revolution of the, or largest revolution, larger time period of the revolution of Neptune. So this is the Kepler's law of planetary motion. Now, any doubts, anyone? You can ask your doubts now. Law of area, is it due to sun's gravity? Law of area is basically, you can say it is because of sun's gravity, but actually, first and third law. Okay. First law is simple, Sonali. First law is nothing. First law says that the planets, they will be revolving around the sun in the elliptical orbit. Okay. So that is law of orbit. That every planet which is there, they will be revolving around the sun in the elliptical orbit, and the sun is located at the one foci. Where is sun? Sun is not at the center. All right. Where is sun? Sun is not at the center. Sun is located at one foci. This is foci. Okay. This is when you will see actually sun is located at one end. It is not at the center of this elliptical orbit. Okay. That is law of orbit. First law. Second law is law of area. The area will be same. All right. The area will be same. That will be there. So on that basis, law of the area, we know that the planets, they revolve with more speed when they are near the sun and with lesser speed when they are away from the sun. All right. Then we have law of the period. Law of the period says that the square of time period of planets revolving around the sun, that is the square of revolution time, that is t square. It says that it is directly proportional to the major axis, semi-major axis. We have one minor axis. Minor axis will be where the sun will be closest. And then we have major axis. So it says that it will be directly proportional to the cube of semi-major axis of the elliptical orbit of the planet. And that is why we know that it is the revolution time. So, of course, we have studied that Neptune has the largest time period for the rotation or revolution, and Mercury just takes 88 days for a complete revolution. All right, clear, Sonali? Clear, Sonali? Okay. Any other doubts? Anyone? Any other doubts so far? I'll share the PDF of this complete PPT in the group that we have for our geography. All right. Okay. Thank you. Then we'll see again tomorrow at the same time. We'll see each of you. All right. And tomorrow we will be covering the Earth. All right. The origin of the Earth, the internal structure of the Earth, that we will cover in the tomorrow session. And most probably tomorrow, if the board arrives at home today, or if not, day after tomorrow, we'll have the session on the smart boards. We'll have the upcoming sessions on the smart boards. Okay. Thank you. Bye-bye. Take care. Jai Hind. We'll meet again tomorrow at the same time. That is at 11 o'clock. Thank you.